Okay, good afternoon. I'm pleased to be here today to give a little bit of I would say, an informal outbrief on the Artemis III site selection workshop that we had in April, which I thought was very successful, and believe me, it's been very useful for us. Okay, but first I wanted to give a little bit of a call out to those who came before us, who got so much right, so well, and so early. So on the left is a figure that was made by one Jeff Placia for the 1990 Site Selection Strategy for a Lunar Outpost report that you can find. Now, if you haven't read it, you all probably should. It's my friend John Gruner likes to say, what has happened before will happen again. And so a lot of the things that we're struggling with our precursors also struggled with, in some cases, almost word for word during the SEI era in the late 80s and early 90s. But if you look at it, the best picture they had of the South Polar region was some pretty low resolution lunar orbiter frames. And so this was one of the best pictures they had in the pre-Clementine era of the South Pole on the left. And on the right is what we have today. The Lunar Reconnaissance Orbiter, 1.7 petabytes of data, the largest data set ever returned by the human species, with a spacecraft specifically designed to meet human spaceflight requirements. And, it's sort of easy to get bogged down and be frustrated sometimes and to, this isn't working as well as it should be. Look how far we've come, and look at this amazing data that we're going to have to work with when we do go back. Okay, so most of you have seen this already. There is a general science rationale for the South Pole, in addition to and beyond the exploration sort of value and the strategic and national posture value of the South Polar region that has been very clearly enunciated for the past 3 decades by folks like Paul Spudis. There's broad science that will be applicable to any South Polar location. The Artemis III Science Definition Team report does provide a pretty good summary of the science achievable at the South Pole. And I think most of you are probably familiar with all those. But the key sort of aspects can be lumped into 2 broad categories: understanding the volatile processes on the moon and their potential for commercial exploitation, and understanding the earliest history of the Earth-Moon system, the bombardment history of the early solar system. So landing sites on the rims of craters offer an opportunity to determine formation ages of these features. Several of the proposed Artemis III candidate landing regions are in areas thought to be quite ancient, but the presence of mapped volatiles both within and outside of PSRs is one of the most very compelling science questions of the program. And so we anticipate addressing that with multiple landed missions with human crew to the South Polar region. Even if they don't directly target volatiles on the first mission, they will still provide important context when we do actually start to go into these volatile-rich areas. So we wound up, and we unrolled with great fanfare a year ago, these 13 candidate regions of prospective interest at the League meeting last year. And we've spent, and they in and of themselves have been down selected from a somewhat larger list that have been assembled based on community reports. You're all going to be very familiar with this figure by, over the next decade or so. But we did actually establish a science rationale for each region. So if you haven't watched Noah Petro's talk at from the Artemis III site selection workshop, you should, because Noah actually goes through and outlines how the process worked, and I'm just briefly summarizing it here, but we did establish actually the CASA science objectives team did actually go through and establish notional candidate science objectives that could be achievable at most of the 13 candidate regions. So, actual thought has actually gone into this. So one of the things we wanted to do with the landing site selection workshop was make sure we didn't miss anything. Make sure, because, I'm smart enough to realize I'm not the smartest guy in the room. So hopefully we didn't miss anything. Hopefully, or conversely, maybe one of these sites really is particularly compelling or interesting. So we didn't want anyone coming into this. There were suggestions we form teams and have the teams like duke it out and, have battling team units or something. And I didn't want that. I wanted instead to have the community focused on what are the unique science potential of each of these sites and what can we maybe address at any one of them. So the agency has established this broad multi-directorate process for establishing where Artemis III is going to go. I will point out that because of the nature of the Artemis architecture and the nature of the hardware systems, a lot of what's going on for Artemis III is going to be unique to that mission. We are landing on the moon for the first time in almost 60 years. We're relearning to do something that, we've forgotten how to do. And so a lot of what's going on for Artemis III is going to be unique to that mission. So we do expect for Artemis IV and beyond additional capabilities, additional means to accomplish the objectives, both science, exploration, national posture, we want to accomplish on the moon. So you'll see here community input, establish figures of merit. I even circled it with community input. That's you. And so we really do want to make sure that this community does get to come along with us and feels included. And it was very important because although it was not necessarily obvious to you on the outside, and because of the nature of how this process is working, a lot of what we have to do is provide the capabilities of our systems. We legally can't do that. And so what we have to do is sort of take in your input and then translate it into engineering and make sure that we're getting it right and make sure that what we learn is applied to the systems. So anyway, there was a major programmatic milestone that was happening in the April timeframe. So it was really important to get that input into the process so that we could actually start to influence some of the programmatic decisions that were being made and are still continuing to be made 3 months from now. So that process is actually ongoing. And it's been a very interesting thing to watch it unfold. Anyway, we're right around here. So last time I gave a talk like this, I'm like, hey, we're at step 3. And now I'm giving here a talk saying, hey, we're still at step 3. Because we want to make sure that we're doing this right. And we also want to make sure we haven't missed anything. And we also want to make sure, above all else, the most important thing in Artemis III is to land and operate safely, because we haven't done this in 60 years, and most of these are brand new systems. So it's probably worth pointing out Apollo was preceded by a bunch of test flights that don't get a lot of attention now or less heralded, but Apollos 9 and 10 were both done explicitly to buy down risk. So Artemis III is very much a test flight in the vein of Apollo 9 and Apollo 10, except it's actually going to the surface of the moon. So again, after we take all these workshop inputs, how am I doing on time? 7 minutes. Okay, so we'll turn on the warp jets. So we had our first workshop in April. It was wildly successful. They had 2 goals: was to communicate aspects of the architecture and then provide a forum for community input. So we had 40 talks, over 300 attendees. We had topical sessions, and based on the abstracts received, we had focus sessions on Shackleton, Faustini, Haworth, the Degerlash Kosher Massif, the Degerlash Rim region, and the Malapert regions that were all established as candidate regions. I'm not reading too much into that because the community is slammed with reports, but it is, I think, interesting to see which sites did garner focused efforts. So I want to run through this very quickly. We had lunar lobate scarps in the South Polar region seem to offer unique opportunities for lunar tectonics. And I thought this was very interesting. Recent LRO results show that Tycho's rays cross several of the candidate regions, which offer interesting opportunities for chronology and understanding, the lunar time stratigraphy. Several candidate regions possibly contain contributions from South Pole Aitken Basin materials, or possibly also other basins like Schrodinger. So that potentially is also very interesting from a mission planning standpoint. Proximity to cold traps will enable interesting things in volatiles for commercial and science applications. And sampling materials from the polar exploration zone will enable us to help understand the dynamics of the lunar magma ocean. These are all pretty big picture questions, but these are all important ones that we've all been discussing for many years. So that was very gratifying in this sort of open community forum to see these sorts of big picture questions float to the top. Other takeaways from the agency. I'll put this in bold and I'll say we heard you loudly and clearly that the community is extraordinarily interested in and invested in this topic. So we can expect there'll be additional workshops as the architecture comes into clearer focus. All the candidate regions seem to offer interesting and unique science objectives, which is very good. A big takeaway, and you saw that, Sarah, we actually respond to this. There's going to be a whole focused workshop on geologic mapping, because it became very clear that a program of systematic geologic mapping to support mission planning and programmatic decisions is really important. So there's one a workshop coming in August on that. So with that, I'll stop. I think there's a Q&A later, but I'm at the conference. If you have questions, feel free to come and ask me about them. So thanks very much.